So by the end of class today, our goal is to be able to identify a direct variation. And that's our learning target for today, which we're going to write at the top.
What is this blur though? I didn't know that this would be. I gotta go and throw this away.
Alright, so our learning target today is I can identify a direct variation. And that's what we're going to be able to do at least with a table by the end of class.
Oh. I'm good.
Hey, wait, put my phone on charge. Alright, are we ready? Hey, Manny. Alright, so this deals with slope, and it's a specific kind of slope. Who can tell me what is slope? Divided by? Alright, take a point. So what's another way to say it? We have the equation. That's slope-intercept form. And that's part of what we're getting to. So we're building the slope-intercept form. But we had another way that we talked about slope yesterday.
Is it M equals
Rise, then run, and y divided by x, right? Both of you take a point. Good, yes. Variation.
Oh.
It's also at the bottom of the paper. Alright, so what we're going to be doing on our table is we're going to look for the change in y divided by the change in x. Now this triangle means change. And what mathematical operation is change? Subtract. So we're going to need to subtract, then divide. So subtract, then divide. So we're going to first talk about specifically what a direct variation is, and then we're going to talk about how to find it. Are we ready? Is anybody ready? Is anybody alive out there?
Yeah.
Alright. Just making sure I'm not teaching zombies. Alright, so at the top, let me zoom in for my blind people.
Thank you.
You're welcome. Alright, so it says a direct variation between two quantities. So quantity means what? A number. Awesome. Take a point. So quantity is a number. So a direct variation between two numbers. So let's write number above it, real tiny. Is the relationship in which the ratio of one quantity to the other is constant. Now, what is a ratio? It is. And how do we represent ratios in math? What? Division. Take a point or a fraction, right? So that's still where we're doing y divided by x. Y divided by x. Every time. Now, our directions say determine whether each of the tables below represents a direct variation. So, we have to find the change in x and the change in y. What does the word change mean? Subtract. So, just in case you don't know how we do the change, we're going to do 2 minus 1. What's 2 minus 1? So that's our change there. Now we're going to do 3 minus 2. What's our change here? 3 minus 4. What's our change there? 6 minus 4, what's our change there? Hi.
Yeah, pretty much.
I have 1.
Appreciate it.
Next time, can you knock? Because we record.
Alright.
Thank you. Alright.
I lived in the same neighborhood since I was in second grade.
Alright, now you can.
Alright, so now we're going to do 12 minus 6. What's 12 minus 6? Then we're going to do 18 minus 12. What's that? 24 minus 18. And what's 36 minus 24?
8, 12, 6.
12. Now, we have to figure out if it's constant. The word constant means that it's the same. Now, we have everything the same up until we get to right here, right?
Yeah.
But what happened between 1 and 2? What did we do? We went up how much? We doubled, right? What happens between 6 and 12? We doubled. So is that still the same? Because our rate increased at the same rate. So, another way that you can check it is divide everything. What's 6 divided by 1?
6.
What's 6 divided by 1 again?
6.
What's 6 divided by 1? What's 12 divided by 2? Is it the same? Yes. 6. So that one is constant because it increased at 6. Is everybody with me? Is anybody kind of with me and may get it better the next time? Okay. Will you turn it on low? Low? It is? Alright, so now we need to figure out B. So if you have a calculator, great, get out your calculator. If you have a cell phone, great, get out your cell phone and use it to subtract. Like, let's go. Okay.
Yeah, not one. Yeah, well.
Alright, so I want you to tell me what negative 2 minus a negative 4 is. Negative 2 minus a negative 4. Positive 2. Alright, what's 2 minus a negative 2?
It is 4.
Okay. What's 4 minus 2? What's 6 minus 4? Are we ready to do the Y's? Now we're still subtracting. Remember, every time we subtract. Now, does everybody notice that I start with the one out front, then subtract this one? Are we noticing how I'm subtracting? Alright, what's 7 minus 14? What's negative 7 minus 7? Negative 14. Awesome. What's negative 14 minus the negative 7?
14.
Positive.
14. No, I mean 7.
Okay, I think it's negative 7.
Thank you.
So let's calm down. Let's breathe. And what's negative 21 minus the negative 14?
Negative 7.
Negative 7. Alright, now we're going to divide. We know that 7 divided by 2 is going to be the same as 7 divided by 2, 7 divided by 2, or negative 7 divided by 2. Does negative 14 divided by 4 reduce to negative 7 divided by 2? Yes, it does. They're the same thing. And if you don't believe me, everybody take your calculator. Do negative 7 divided by 2. Or your cell phone. Either one. Put the minus. Give me just a second. Alright, and then do negative 14 divided by 4. Oh my gosh. What's negative 14 divided by 4? Is it the same thing? So is this a direct variation? Yes, it is. And what is the direct variation? What's our slope? Negative 3.5 or negative 7 divided by 2. All right, are we ready for C? You guys want to try C without me? Or you want to do one more together? One more together? Okay, that's fine. All right, so again, we're subtracting. Negative 4 minus 8.
Negative 4.
Negative 12. All right, 96 minus negative 4.
Oh,
0.4 minus 96.
Oh, that's easy.
0.8 minus 0.4. So negative 12, 100, negative 95.6, 0.4. Now, so far, that looks like chaos, doesn't it? But we're going to do our y's just to make sure. All right, what's negative 12 minus 6? Negative 18, right? What's 0.5 minus negative 12? What's 120 minus 0.5? And what's 40 minus 120? Dude, you have a calculator in front of you. Subtract. Alright, now I want you to divide each of those. What's negative 18 divided by negative 12? One person, I want one person to do negative 18 divided by negative 12. Who's going to do that? Alright, Allie's doing that one. One person do 12.5 divided by 100. Who's going to do that? Alright, Manny's doing that. David, do you want to do 119.5 divided by negative 95.6? Alright, divide that. Who wants to do negative 80 divided by 0.4?
I did.
Alright, Troy, do those. Now, divide and tell me what you get. Allie, what'd you get? 1.5. Manny, what'd you get?
Hold on, 0.4?
125.
0.125. Alright, Troy, what'd you get?
Negative 200.
Okay. And David, what'd you get?
Negative 1.
Are those the same? So this is not a direct variation. No. And we can kind of see that from the chaos in the table, right? That doesn't make sense at all.
Yeah, it's too much longer.
But we're going to check D. I want you guys to subtract D without me. I want you guys to do the X and then the Y, and then we're going to divide together. What did we get for, I'm going to do this in light purple. 80 minus negative 32.
Negative 112.
Positive 112, because we increase. Yeah, it's positive. All right, what about negative 48 minus 80?
Negative
8 minus 48?
86.
56. 24 minus 8?
10.
24 minus 8 is 16. We're not dividing, we're subtracting, guys. Subtract. Subtract first. All right, who got all four right? Look at you go. 112. All right, what's 5 minus negative 2? And then I got negative 8. And then I got 3.5. And then I got 1.
I already know you know.
Yeah, because it's negative 3 minus 5. Okay, now, who thinks it's a no? Who thinks we should probably divide and wait and see? I think maybe we need to divide. So, one person, I want one person to do 1 divided by 16. Alright, David, 1 divided by 16. One person do 3.5 divided by 56.
I got negative 16.
It's positive because it increases. Alright, you're doing 3.5 divided by 56. Thank you. Who will do negative 8 divided by negative 128? Alright, Mackenzie's doing negative 8 divided by negative 128. And Ava's going to do 7 divided by 112. Okay, that's okay. Alright, so Mackenzie, what did you get? 0.625. Troy, what'd you get? 0.0625. Alright, David, what'd you get? Okay, Ava, what'd you get? Divide, baby. 7 divided by 112. Divide. Yes. So what do you guys think this one is?
Yes.
It's a yes. 0.0625. So remember, subtract, then divide.
Oh, what kind of ring is that?
Subtract, then divide.
I think I might want this one.
You divided the other way. Y divided by X. Bottom divided by top. Yeah. Now, it has to be a constant. This is still slope, because remember when we do slope, we do y2 minus y1 divided by x2. That's still the same thing. That's what we're doing. We're just doing it in table form. And remember, we did it in table form the other day. That was our first flappy we did. Do you guys remember that? Do we need to look back and see? Okay. All right, so we're going to do one more part, and then you have no homework tonight. So now we're going to talk about an equation form. Do you guys remember y equals mx plus b?
Yes, I do.
Okay, what does the m stand for? Slope. What did the b stand for?
X, Y. Slope. Like, no, wait, don't tell us.
Helium.
I know it. I gotta look at my notebook.
God,
I'm just saying random stuff.
what is B stand for?
Bread.
Y-intercept.
Why
So on this one, we have y equals kx. So we're going to say that k is our slope. So we're still dealing with slope. Now, do we have a y-intercept out here?
Yeah. No.
Do you see anything out here? Was that it?
No.
Okay. So the y-intercept is 0. So now, for it to be a direct variation, it has to have a constant slope, and it has to pass through 0. Guys, that's a cursive K.
R.
See, I told you, dude.
So I can't have nice things.
Start letter of my first name.
All right, open it up.
Open it up.
Now, a direct variation can be written as an equation in the form of y equals kx. And what does k represent?
Y equals R. You said slope.
The slope. K represents the slope.
Y equals
Take a point, CJ.
What did I say?
Just in case you didn't know this in the past 6 months, I say what I write. I do. It's crazy. 1 month, 3 days.
So funny. He said. Yeah, walk from it. Yeah, walk from it.
I don't care. But it's a trip with me and my mom.
And your best friend.
And my best friend. Alright, so it says, tell whether each equation represents a direct variation. If so, identify the constant of variation.
Oh, he said he
So-
said the H word.
Do your 5
No, I
push-ups.
did. No, I did.
Yeah, you said it.
I didn't even say it. How did you not hear him? You always hear me when I say it.
Push-ups. Yes, you did. And now you're lying, so that's 5 more.
Oh. She did. She didn't even hear me. I can't do push-ups. I'm weak. I've never done a push-up in my life.
We're aspiring to greatness. Let's go.
I can't do push-ups.
I kind of wish I never did push-ups.
Alright, now, for it to be a direct variation, it has to be in the form of y equals kx, and it cannot have a y-intercept. So it can't have a plus anything out here. So now A, that's a direct variation. So we say yes. And then it says identify the constant of variation. That's always the number in front of x. So what number is in front of x? 6. So K equals 6. That's all you do. You did not do your push-ups. You walked over there. You must think I'm stupid.
I got 10.
You have 10
I had
because you lied.
Yeah, you.
Beautiful. Alright, now B. Now remember, the y-intercept has to be 0. What's our y-intercept here? Negative 1. So is this a direct variation?
No.
No. Alright, what about C?
Yes.
Yes, it is. And what is K in this situation? 1/2. What about D? First, we have to get y by itself. How would we get y by itself? Divide by 3. Awesome. If you said divide, take a point. So what's 6 divided by 3?
3.
Adam, 2. So take a point. Now, is this a direct variation? Do we have a y-intercept? Do we have a y-intercept?
Yes.
We don't have a plus anything.
Oh.
So this is a direct variation. Yes. And what does K equal?
2.
Awesome.
Oh, these two? Okay.
For homework, I would like you to try E, F, and G.
Well, you said we weren't even have homework.
Congratulations.
You said E.
You don't do your homework anyway, so what does it matter? E, F, and G.
It's not one time that I've had it.